What is a proportion and how do you solve them? This video is for chapter 7, section 1 out of your textbooks. Here's a reminder of what your notes should look like to take notes from this video. There are many uses of ratios and proportions. We use them in map reading, making scale drawings, and models, and also solving problems. And if you look here, if you measure this key with a ruler and you figure out from 0 to 10 miles how many inches or centimeters that is, you can actually help you measure the distance on this map using a ruler and then using proportions or ratios to get to how many miles it would be. The most recognizable use of ratios and proportions is drawing models and plans for construction. Scales must be used to approximate what the actual object will be like. And here's an example. You wouldn't really start building a home, you would first lay it out, and this would be a type of scale drawing that you can use, and then you can multiply by the scale in order to figure out how you would build it using wood and nails. A ratio is a comparison of two quantities by division. In the rectangles below, the ratio of shaded area to the unshaded area is 1 to 2, or 2 to 4, or 3 to 6, and 4 to 8. All the rectangles have equivalent shaded areas. Ratios that make the same comparison are equivalent ratios. So if you went ahead and reduced 4 over 8 and 3 over 6 and 2 over 4, you would reduce it all to the same, which is 1/2. Notice that this half of the rectangle is being shaded for each shape. A ratio can be written in a variety of ways. You can use ratios to compare quantities or describe rates. Proportions are used in many fields, including construction, photography, and medicine. And here's the different ways that you can write a ratio. They all mean the same thing, A to B, A to B, or A to B. Since ratios that make the same comparison are equivalent ratios, they all reduce to the same value. Like I showed you with the pictures in the shaded rectangles, if you reduce 2 over 10s or 3 over 15, you will get 1/5. So these are equivalent ratios. A proportion is an equation that states that two ratios are equal, such as 2 to 3 equal x to 9. And you can, I would underline some key words like what a proportion is. It's an equation that states that two ratios are equal. In simple proportions, all you need to do is examine the fractions. If the fractions both reduce to the same value, the proportion is true. Let's underline some of that. They have to reduce to the same value that the proportion is said to be true. So you really have to think, are these two are these two ratios equivalent? Is the proportion true? Well, if we divide both sides and reduce them as far as we can, we will get 1/3 for each one. That equals 1/3, this equals 1/3. How does that happen? We divide this number by 5 and the bottom number by 5 to reduce it to 1/3, and then over here on this side we divide it by 2 and by 2 to reduce it to 1/3. So the proportion is true. In simple proportions, you can use the same approach when solving for a missing part of a proportion. Remember that both fractions must reduce to the same value. Let's take a look at this proportion here. You really have to think, what number could we plug in for x, or substitute in for x, that if you reduce this ratio, it would equal to 2 over 3. Or you can use some basic algebra and you can cross multiply to find that missing value x. So we do 3 multiplied by x is equal to 2 multiplied by 9. We get this simple equation, we solve, and we get x equals 6. You can then take this answer and plug it back in, reduce the fraction, the ratio, in order to get 2/3, or you can just plug it back into the simple equation that you created and see that it's also true. So 6 does check out. Here's an example for you. Are the following true proportions? That means, do they reduce to the same values? Go ahead and pause the video, write down the examples, and then replay when you're ready to follow along with me. Okay, I hopefully you pause and try these on your own. And let's take a look at what I wrote down so far. If you look on the first example here, I could not reduce 2/3, so I reduced 10 over 5 by 5s, and I got 2 over 1. And since they are not the same proportion, since they're not the same ratio, this proportion is not true. Let's try the second one. Take a look at the second one. Can't reduce 2/3, but I can reduce 10 over 15 by 5s, and I get 2 over 3. Since these ratios are equivalent, then the following proportion is true. So this is yes. Oops, weird yes, true. Okay. Okay, this is a review concept for geometry, so you should be used to solving proportions. So I'm going to let you write down this example, try it on your own, and then when you're ready to check your work, then play the video. Okay, now you can check your work. So we cross multiplied and got 6x equals 4 times 42. 4 times 42 is 168. Divide both sides by 6 and x equals 28. And go ahead and check your answer on your own. Okay, here's another example. Go ahead and write this down. Pause the video, and when you're ready to follow along with me, you can check your work. Okay, there's the answer. Hopefully you were correct. If you weren't, go ahead and double check your work. Okay, here's 2 more examples that are actually word problem-based examples. However, I'm not going to solve them or display the answer. I'd like you to bring your work to class, and we'll discuss these 2 questions together.